Next, I'm going to take these equations, we're going to actually use them in a problem solving. So here we go. My first problem reads that 3.50 grams of sugar is dissolved per 85.5 grams of solution. Remember, your solute is divided in the solvent and forms a solution. So your solute is what's being dissolved. So you realize here in the situation, it's asking for what is percent of sugar by mass. Well, I have my solute and I have my solution in grams, so it's percent by mass. So I take my 3.50 grams divided by my 85.5 grams of solution times 100, change it to a percent. I realize my solution is made up of 4.09% sugar. My next question reads, I have 12.5 milliliters of alcohol is dissolved in 128.4 milliliters of alcohol solution. What is the percent alcohol by volume? So my alcohol, my solute, is dissolved in my solution. So I'm going to take the part divided by the total, but this time I'm using volume, so it's called percent by volume. But it's just the same math. I take my 12.5 milliliters divided by my 128.4 milliliters. My units cancel out. As you can see here, it doesn't matter what your units are. They just have to be consistent because they will cancel out. So you can use centimeters cubed, milliliters, liters, it doesn't matter. Again, the volume units will cancel out. And I end up with 9.74% alcohol in the solution. My last example, I have 4.44 grams of sodium chloride is dissolved in 122 milliliters of solution, and I want to know its molarity. Well, molarity, again, dealing with a solution, I have a amount divided by a volume. So you have your amount is 4.44 grams, and you have your volume at 122 milliliters. Now, molarity, your amount has to be in moles, and your volume has to be in liters. So I'm going to write out my grams, and I have 4.44 grams of sodium chloride per, I'm going to take my milliliters and adjust it to liters really quick. That's just simple metric to metric. I'm going from milli, it's the thousandth, move my decimal 3 places back to the left, and 122 milliliters the same as 0.122 liters. So I have my amount over my volume. Now my volume is correct in liters, so I don't have to do anything like this. Remember back, this is just like we did with dimensional analysis at the very beginning. Like I gave you a problem in miles per hour and I wanted you to change it to meters per second. And so we're running into the exact same setup right here with dimensional analysis. My volume's fine. My amount though is in grams. It needs to make to moles. So how do I get from mass to moles? Molar mass. And we get molar mass from the periodic table. Good job. So look up sodium chloride. Sodium chloride weighs in at 58.44 grams per every 1 mole. Put moles for grams for one reason, so my grams cancel out and I change to moles. Now I have moles per liter. All I simply do is take my 4.44 divided by 0.122 divided by 58.44 equals, and I get my amount here, and my amount is 0.623 molarity sodium chloride solution.